Bismillahirrahmanirrahim. We welcome you in our basic advanced physics YouTube channel. Today we are going to talk about the topic that is the ruby laser. Ruby laser basically was the first laser that was fabricated by Theodore Mammon in Huck's research laboratories in 1960. Next, the structure of the ruby laser. So this is the ruby rod that made up of aluminium oxides and the chromium oxide. In practical lasers, flash lamps of helical designs are no longer used. The most common types are the linear lamps. But here for understanding, we are taking a xenon flash lamp. And this xenon flash lamp is to be connected with a switch and a power supply. Now a capacitor is to be connected parallel to the xenon flash lamp, and this is a switch. Now this and this are the mirrors called to be reflecting mirrors. Okay, and one mirror is 100% reflecting, while the other mirror is 90% reflecting. And 10% transmitting. This mirror is completely silvered, while this mirror is partially silvered. Now we discuss the construction of the ruby rod. The ruby laser rod consists of a synthetic ruby crystal, aluminium oxide doped with the chromium ions at the concentration of about 0.05% by weight. At this concentration there are about 1.6 × 10⁻25 chromium ions per cubic meter are present, or you can say that 0.05% of aluminium ions are replaced by the chromium ions. Now the length of this ruby rod is 4 cm and its width, or you can say its diameter, is about 0.5 cm. Now we discuss about the xenon flash lamp. Basically, xenon flash lamp produces 1000 joules of energy in a short time, or in a millisecond, and it heat up the whole system. To cool down this system, we use the cold water. Now we'll talk about the working of the ruby laser. As this is the energy and the other is ground state on x-axis. Now these are the energy states of the chromium ions. E1 energy state, E2 state, E3 and E4 energy states. And E2 basically that is the E2. E2 basically shows the two energy levels that are the closely spaced, and it is also called the metastable state of the chromium ions. When xenon flash lamp flashes, it produces 1000 joules of energy that is to be used to pump the electron to the excited states like E4 and E3 energy states. Now, the chromium ions are present into the excited states of E3 and E4. Here, the lifetime of the chromium ion is 10 raised to the power minus 8 second approximately. After that time, the chromium ions comes down to the metastable state. Here, the lifetime of the chromium ion is 10 raised to the power minus 3 second. That is the higher time rather than the other energy levels like E3 and E4. Now the chromium ions come down to the ground state, but it does not comes down on its own. It comes down due to when one of the spontaneously emitted fluorescent photon traveling parallel to the axis of the ruby rod would initiate the stimulated emission here. Due to that stimulated emission, now chromium ions comes down from E2 to ground state E1. From E4 to E2 and E3 to E2. That is the non-radioactive transition. Radioactive transition only occur when the chromium ions comes down from E2 energy state to E1 energy state. Now when chromium ions comes down from metastable state to the ground state, it produces the laser light. One is the fluorescent photon and the other is produces due to the de-excitation of the chromium ion. That is also the radioactive transition. Now for understanding, from E2 to E1 ground state, it is the radioactive transition. And from E4 to E2 and E3 to E2, that is the non-radioactive transition. Now what is the population inversion? In this case, population inversion is basically to increase the number of electrons into the metastable state is called the population inversion. Now we'll talk about the laser action. In laser action, let's suppose, just for understanding, we are taking a chromium ion here, like this is the nucleus, this is the first energy level, second energy level, and third energy level. There are present the, let's suppose, 7 electrons in this here. 8 electrons in second shell and in first shell 2 electrons. When xenon flash lamp flashes, it produces a photon of light. This photon of light absorbed by the electron in ground state and it jumps to the excited state. Then it remain here only for 10 raised to power minus 8 seconds. Then it turn to the second energy level. Now one of the spontaneously emitted fluorescent photon traveling parallel to the axis of the ruby rod would initiate the stimulated emission here, and this electron in second energy level jumps to the first energy level and causes the production of the two light photons that are the laser light. These two light photons are coherent and in phase. One of the light photon is produced due to the de-excitation of the electron, and the other is the fluorescent light photon. Now these two light photons stimulate the other chromium ions, like it is the one chromium ion and it is the second chromium ion. Just for understanding, for example, these are the two light photons here strike with the one chromium ion and stimulate it and produces two light photons, and the second light photon also stimulate one chromium ion and produces the other two light photons. Now these two light photons stimulate the two chromium ions and produces the four light photons. Now these four light photon also stimulate the other four chromium ions and produces the 8 photon as a result. Now the intensity of these light photons continue to increase, and so on. This process is to be continued. These light photons now moves back and forth between these two mirrors, that one is the partially silvered and the other is the fully silvered mirror, and stimulate the other chromium ions, and in this way, as a result, we obtain the laser light. Moves back and forth between the mirrors. These are the light photons, and so many light photons are present here, and these light photons are in phase. And one more thing, that the photons are the bosons and does not follow the Pauli exclusion principle. So these are in phase, intense, and also high directional. Now we talk about the spiking behavior of the ruby laser. The xenon flash lasts for a few milliseconds, however the laser does not operate throughout this period. Its output occurs in the form of irregular pulses of microsecond duration. Now it is the output, and in lower diagram it is the input, and on the x-axis this is the time here. It is the time on the x-axis. In the lower diagram, this is the input that we are given to the chromium ions by the flash lamp. Now for the time that is 0.5 seconds, we are not getting the output laser, because during this time the chromium ions from the ground state go to the excited state, remains here for a short time, then comes down to the metastable state. Their stimulated emissions occur, and we obtain the laser as a output. We obtain laser light as the output when xenon flash lamp flashes first, but before that it flashes again, immediately metastable state depopulated. So as we can say that the stimulated transition is faster than the rate of the maintenance of the population inversion. So here, so for that time, that is 0.5, we are giving the input by xenon flash lamp, but we are not getting the output because the population inversion has not achieved yet. But after that we get the pulses of light as the output. So we can say that in ruby laser we only obtained the flashes of the light, not the continuous laser. So next, here the characteristics of the ruby laser. First, the optical pumping is to be used in it. Second, it is the 3-level laser. Third, it works in pulses mode. And the fourth, it is the solid state laser. So here are some of the uses of the ruby laser. It used to destroy the cancerous and precancerous cells, to drill the tiny holes in hardest materials like steels and diamonds, for the telecommunication along the optical fibers, to induce the nuclear fusion reactions, to generate the three-dimensional images of the objects in holography, to destroy the tissues in a localized area, and as a rangefinder over the large distances, and so on. Thanks for watching. Subscribe our channel and press the bell icon for getting the notifications of upcoming informative videos.